Okay, for some crazy reason, the video did not take today, so I'm going to go ahead and run through this. It's going to be a little bit abbreviated, so you'll have to just really pay attention and come in and see me if you have questions or talk to some of the kids that were here. So we're on 5.6 now, and the directions are the same as they've been. We have to solve this triangle. Now, when you look at this triangle and you think about solving it, it would make sense to say sine 58 over c. That would make sense. But then what are you going to set that equal to? Sine h over 10? Too many variables. Sine s over 12? Too many variables. The law of sines, while it produces a true equation, it produces an unsolvable equation in this situation. Remember, if you're going to do the law of sines, if you're going to set up that proportion, you have to have one set. So if I had side C, I'd be good to go, but I don't. So this is going to be a law of cosines problem. Now, when you do the law of cosines, it's really very easy, and it's the pattern that you want to pay attention to. The angle, the only angle of the problem is right here at 58. So I'm going to put cosine 58 right out here. And I'm going to leave some space, and that's going to equal c squared. So when you write your law of cosines, which is a long equation, when you write it, on one end goes a side squared, and on the other end goes the cosine of the angle. And the side squared that you're using must match up with the angle that you're using. So since this is angle C, this is going to be c squared. Now, all the rest in the middle is a combination of work with the other two sides, so the 10 and the 12. So the law of cosine says 10 squared plus 12 squared minus 2, 10, 12, cosine 58. So it's one of the sides squared plus the other side squared minus 2, always 2, times those two sides times the cosine of the angle. This is all one term. Okay, so I'm going to type that in on my calculator now. And since this is my variable, I can just type this in. So 10 squared plus 12 squared minus 2 times 10 times 12 times cosine 58 equals, now you get 116, but that is c squared. So we're going to have to take the square root of that. So you can hit second square root, second answer, and your answer button is right down here at the bottom. And that'll take the square root of that. I don't want you typing it back in. I don't want you writing down this 116 number. Just take the square root of it right on your screen. And that's 10.81. Now look at what you have. Now you have this match set. Now you have an angle and its side. So now we can do the law of sines. So we can say sine 58 over 10.81 equals sine s over 12. So 10.81 sine s equals 12 sine 58. So sine s, not angle s, sine s equals 12 sine 58 over 10.81. So to get angle s, which is what we're looking for, this is just going to give you a decimal. This is going to give you the sign. You don't want the sign. You want the angle. So second sine that fraction. So here we go. Second sine 12 sine 58 divided by 10.81. and I got 70.29. So then angle H is easy. We'll just add that to 58 and subtract from 180. So that one's 51.71. And there we go. Triangle solved. Okay, now let's try the next one. The next one, we have all three sides. So 3.2, this is CHS, not ABC. So H is 7.6 and S is 6.4. So there's my triangle. And I'm going to solve it, that's what the directions say, which means find everything I don't know. And it looks like what I don't know in this problem is any of the angles. Now, am I going to be able to use the law of sines? No, because once again, if you're going to use the law of sines, you have to have a complete pair. If you don't have any angles, you're not going to have an angle on any side. So this is going to be another law of cosines problem. If I knew this angle was 54, then, or something, then I could do my law of sines. But because I don't have any of the angles, it's a law of cosines problem. So here we go. Got to pick an angle to find. And I always, if this is my situation, I like to find the big one first. There are some reasons for that, but if you just always shoot for the big one first, everything will be fine. So the big angle in this picture would be H, because it's across from the biggest side. So in my law of cosines, remember, on this side goes the side squared, and out here on the end is going to go cosine H. When you write the law of cosines, on one end goes the cosine, and on the other end goes that side squared. So since I've decided I'm finding H, and you could find C and you could find S, I'm finding H. Since I'm finding H, 7.6 squared goes over here. Now, the middle part here is just a combination of the other two sides. So this is the one I've written down already, these two sides. So 3.2 squared plus 6.4 squared minus 2 times 3.2 times 6.4 times the cosine of H. This is all times. That's the pattern for the law of cosines. It never changes. It's always exactly that way. Now, this one's a little bit tougher to type in because your variable is not all by itself. Your variable is kind of buried in the problem. So I would suggest, you don't have to do this, but if you're a little bit intimidated by that equation, I would suggest that you go ahead and square 7.6, and that's 57.76. And then you go ahead and add these together, so 3.2 squared plus 6.4 squared, there's nothing wrong with that, that's 51.2. And then go ahead and multiply these numbers together, so 2 times 3.2 times 6.4 is 40.96. Cosine H. Remember, all that is hooked to cosine H. And because of that, you cannot subtract these two numbers. This one does not have an H. These are not like terms. So instead, we're going to subtract the 51.2. And we have 6.56 equal, excuse me, to negative 40.96. cosine h. Now I'll divide, so 6.56 over negative 40.96 equals cosine h. Now, we're right where we were a second ago. This is not the answer to the question. This is the cosine. We want h. So h will equal, what will h equal? Second cosine, 6.56 over negative 40.96. So second cosine, 6.56 divided by negative 40.96. And I got 99.22. So angle H is 99.22. Now notice, as soon as I did that, what have I got right here? I have my pair. So now, I gotta finish the problem, I still need C and S. Now I can set up my law of sines. Sine 99.22 over 7.6 equals sine S over 6.4, or sine C over 3.2, whatever one you want. You gotta do one of them, whichever one you want. So sine S equals 6.4 sine 99.22 over 7.6. Here we go again. You can go ahead and type that in, but that is not the answer. That is the sign. To get the answer, you're going to second sign or inverse sign. 6.4 sine 99.22 over 7.6. And that's 56.22. And then, of course, to find angle C, you'll just subtract from 180, and that's 24.56. And there you go. That's a lot. Problem C, I need to change some stuff. I don't know what I was doing. I don't know what I was doing. So make it side H is 11 and side S is 10. So angle C is 57, side H is 11, and side S is 10. And we're going to solve this triangle. Now, on your quiz day, your quest day, you are not, the problems aren't going to be separated. They're just going to say, solve this triangle. So you're going to need to be able to look at the triangle and decide if you're going to use law of sines or cosines. It'll be one or the other. You'll either use sines or cosines to solve the problem. So looking at this one, which do you think it is? Is this going to be a law of sines problem or a law of cosines problem? Well, I hope you're saying it's a law of cosines problem, because you do not have a pair. You don't have angle C inside C, you don't have angle H inside H, you don't have angle S inside S. So it's going to have to be the law of cosines. And the angle we've got is 57, and that matches up with side C. So there's my initial framework for my law of cosines. Cosine angle, clear on this end, and that angle's side squared on the other end. And then in the middle is going to go your combination of 10 and 11. So 10 squared plus 11 squared minus 2 times 10 times 11 times cosine 57. This is all hooked together here at the end. Because you are solving for a variable that's already by itself, you can type it in. You can do it in pieces if you want, if that makes more sense to you. But watch, don't do any rounding off and stuff. And again, you're going to get c squared, so you're going to have to square root that. So second square root, second answer, and you get 10.06. 10.06 for side C. Now that you have side C, you have your pair. So you can say sine 57 over 10.06 equals sine H over 11. So, or you could also do S. Doesn't make any difference. I just picked H. You could do S. You gotta do one of them. So for me, sine H equals 11 sine 57 over 10.06. So remember, this is not the answer. You need H. So H will be second sine or inverse sine. 11 sine 57 over 10.06. So second sine, 11 sine 57, remember close parentheses after the 57, divided by 10.06, 66.5. So H is 66.50. Subtracting from 180, we get 56.50 as angle S. Now in class we actually went through a derivation for this next set of problems, but I'm not going to do that. I wish the video would have worked and it didn't. But I'm going to check to make sure it's working even now. It's been a little temperamental. Yeah, so we're going to, I'm just going to jump in and show you a couple of new ways of finding area of triangles. You have your old standby. 1/2 base times height. That will always work. That will find the area of every triangle. But because we don't always know the height, there are a couple of alternatives I want to share with you because I think they'll make your life easier. The first one is the new area formula that you're going to write down is that area can be found, area of a triangle can be found by taking 1/2 side times sine of included angle. So we call this 1/2 side sine, but it's important that you take the sine of the included angle. So for this problem right here, letter A, you have exactly what you want. You have two sides, side, and you have the included angle. The included angle is the angle that the sides make. This is not the included angle. This is the included angle for these two sides. So the area is just going to be 1/2, 32, 19, sine 47. That's it. That's the area of the triangle. You just type it in, and that is it. How about 222.33? Again, since I messed it up the first time. Yeah, that looks good. So the area of the triangle is 222.33. So that is one of our new ways. I'm going to give you another one here in a bit. But that's one of our new ways of finding the area of a triangle. Now, that one was set up perfectly exactly the way we needed it to be set up. Let's look at the next problem, B. Now your job is to find the area of this triangle. What is wrong with it? Well, we need 1/2 side sine, and we do not have, we have angles, but we only have one side, and we need 2. So before we can find the area of this triangle, we're going to need to find another side. And how are we going to do that? We're going to use the law of sines. Now let's see. Sine, this is side A over here. So sine 57 over 12 equals sine 43 over A. So cross multiply and divide. So A equals 12 sine 43 over sine 57. Now, please don't get any crazy ideas about second signing or something. This says A equals. It doesn't say sine A equals, it says A equals. Just type it in. 12 sine 43, 12 sine 43, divided by sine 57. I got 9.76. Now that I have 9.76 on my triangle, now I can find the area because I have 2 sides. So the area is going to be 1/2 12 times 9.76 times the sine of the included angle, which is this one, which is 80. If you found side A, then you're going to use side 12 and side A. This is the angle you have to use. Now, here I could have just as easily found side C, doing the same thing. I could have found side C. Then my area would have been 1/2 12 this sine 43. When you do your area, you must use the included angle. Now, this number's sitting on my calculator, so instead of retyping it in and rounding it off, I'm just going to use my second answer button. So 0.5, 1/2, times 12, times second answer, times sine 80. And now I have an unrounded off thing. My area is 57.66. So, new area formula, 1/2 side sine of included angle. What's my caution to you? You must have 2 sides and the included angle. If you do not have what you need, then you're going to use the law of sines or cosines to find it, which is exactly what we did. We used the law of sines to find the missing side, and then as soon as we had that side, we had our area. Now, an exception to that strategy could be this situation. So if we need to find the area of triangle C, obviously what are we missing? An angle. And we can use the law of cosines to find that angle. So a little bit ago, we had a triangle like this, and we found the biggest angle, so that would be like angle A. You can find it. And once we know angle A, using the law of cosines, then we can do 1/2 12 or 12/10 sine A. But this is a special case. When you know all 3 sides, you can actually find the area in a quicker way than going through all that. Will all that work? Finding the angle with the law of cosines and doing 1/2 side sine. it absolutely will work. But a quicker way is using Hero's formula. His name was actually Heron, but it's been abbreviated to Hero's formula. And Hero's formula says that if you know all three sides, and that's the caveat, folks, you gotta know all three sides. Please don't use Hero if you don't know all three sides. But if you do know all three sides, the area can be found using this little formula. So 4 things underneath that big radical. There's an S minus A, S minus B, and S minus C. Now, the little a, little b, and little c are the sides of this triangle. So 10, 16, and 12 are your A, B, and C, and the order doesn't matter, okay? Now, what's the S? Well, the S is the semi-perimeter. That's why Hero's formula works if you know all three sides. Because if you know all three sides, you know the perimeter for this one is 38, perimeter, distance around, and then the semi-perimeter is half of that, or 19. So to find the area of this triangle, you have your radical, and then under your radical, we'll start with 19. It starts with the actual semi-perimeter. And then you take the semi-perimeter minus each side. No order matters, okay? Don't worry about it. Just take 19 minus each side. So 19 minus 12, 19 minus 16, and 19 minus 10. Now, do yourself a favor and don't just write down these numbers, because next time you look at it, you won't remember where they came from. So where did this 7 come from? That's 19 minus 12. 19 minus 16, 19 minus 10. And then to get your area, you're just going to multiply those 4 numbers there. 19 times 7 times 3 times 9, and then second square root, second answer, and it's 59.92. It's as easy as that to find the area of a triangle if you know all three sides. Obviously, you cannot do Hero's formula if you don't know all three sides, because the foundation of Hero's formula is the semi-perimeter. And if you don't know the perimeter, you can't do it. And the only way you know the perimeter is to have all three sides. All right, well, there's one more of those. Let's give it a shot. Problem D. Side A, side B, side C. And somebody in class asked me if it mattered where I put my big A, B, and C, and the answer is no. How you orient your triangle that's up to you. But remember, if this is angle A, then this has got to be side A. If you put angle A up here, that's fine, but then this is side A. So just make sure that your sides are lined up with your angles. All right, so here we go. We're going to do Hero's formula. So the first thing we need to do is find the perimeter. And then we're going to cut it in half. And then we're going to be able to find our area. All right, so here we go. I got 48.7. Did I write all these numbers down right? I hope I got 48.7 for my perimeter, which means half of that will be 24.35. And that's the number that goes in the radical. Look at me. 48 does not go in the radical. The semi-perimeter goes in the radical. And then the other numbers are that minus each side. Wait a second. What happens when you take 24.35 minus 28? Don't you get a negative something or other? And what happens when you take the square root of a negative? It's imaginary. Guess what? This triangle does not exist. This triangle does not exist because the semi-perimeter is 24, and when I do 24 minus 28, I'm going to get a negative number, and when I multiply it all together, it's going to be negative, and when I take the square root of it, it's going to be imaginary, which means the triangle is imaginary. It does not exist. And thinking back to geometry, that makes perfectly good sense, because you recall from geometry that two sides of the triangle always have to be more than the third. This is not a triangle because 12 and 8 do not add up to more than 28. So this is an impossible situation. You didn't need to remember your geometry though, because Hero's formula told you that it isn't going to work. All right, one more, 3A. Find the area of a regular hexagon inscribed in a circle of radius 12. All right, so let's draw a picture of this. There's my circle. What does hexagon mean? 6. So I'm going to put 6, as best as I can, evenly space these 6 hash marks around the circle. And then I'm going to connect them. And there is my hexagon inscribed in a circle with a radius of 12. So from the center to this point is 12. From the center to this point is 12. And to this one, and this one, and this one, and this one. Those are all 12s. Now you don't necessarily have to draw all those in there, but now that I have, can you see that my hexagon is really just 6 congruent triangles? So if I could somehow find the area of this one, I could just times it by 6, and that would be the area of the hexagon. Agreed? So I need the area of the triangle. Well, we've got a new formula that says area is 1/2 side sine of included angle. So if I had this angle, right there, side, if I had that angle, everything would be perfect. I'd be all set. Well, believe it or not, you do have that angle, and you've probably already figured that out. All of these triangles are congruent. And there's 6 of these angles, and they're all equal. And they add up to 360. So if there's 6 of them, and they add up to 360, then that one has to be 60. 360 divided by 6. So the area of the triangle is 1/2, 12, 12, sine 60. And you can type that in. Before we finish the problem, because that, remember, is just the area of the triangle. To get the area of the hexagon, we're going to have to multiply that by 6. 6 times the triangle area. But before we do that, I want you to think about, what if that had been a pentagon? Well, your strategy would be exactly the same. But if it's a pentagon, you would only have 5 triangles. And the central angle then wouldn't be 360 divided by 6. It would be 360 divided by 5. And you could find the area of your triangle, times it by 5, and that would be your pentagon. Decagon, octagon, doesn't matter. Whatever agon you've got, you can use this strategy to find its area. Okay, well, let's finish the problem. So 1/2 times 12 times 12 times sine 60. Now this is the area of the triangle. I'm not even going to write it down. I just need to do times 6. And the area of the hexagon is 374.12 square inches. We're going to stop here. We have 3 more problems, I believe. 3 more problems to do, and then we'll review and we'll take our quest. So we'll, next class, we will finish this and do the review, and then the class after that, we'll have our quest over 5.5 and 5.6, law of sines, law of cosines, and area. See ya!